The second way that we will look at how superposition of waves causes an observable impact is in beats. So beats occur when you have two sounds that are at similar but slightly different frequencies. If you are a musician, then you know, you know. We are going to look at an example here of a wave. This is pretty similar to what we saw in the video on interference. We have a wave coming from the left-hand side, and it's just traveling along, minding its own business. We're going to add to that another wave that's traveling along slightly differently. It's just going to have a slightly different frequency. This is a larger difference maybe than we would normally see, but I just wanted to make it easy to graph. And so you can see that the blue one is traveling just ahead of the red one. And again, if you are somewhere in the space of these waves, then what you observe is not the individual waves, but their superposition. You hear the two sound waves added together. And so that result is this purple one. And I'm going to turn off the red and the blue so we can see just the purple. And the main thing to notice is when you look at the purple wave, its amplitude as it goes through time changes. Right? So you have a loud, and then soft, and then a loud, and then a soft. Right? So this variation in the intensity of the sound is what we call beats. And we can calculate the frequency of the beat. In fact, we can see that here. So we're going to wait for it to be at its maximum amplitude again after I stop speaking. Max. So it's at its maximum amplitude, and it's at its maximum amplitude, right? So it took that 20, if these are in seconds, it took 20 seconds to go from a maximum amplitude to the maximum amplitude again. So 20 seconds is a frequency of 0.05 seconds. Well, do you see any numbers on these graphs that could give you a 0.05 seconds? It's the difference, right? So the frequency of the beat wave, the beat that you actually observe, the total superposed wave, is just the difference in frequencies of the individual waves. This was, again, going to be an in-class demo. There's no convenient way for me to replicate that with Desmos, but the thing I would write down is that the frequency of the beats is the absolute magnitude of the difference in frequencies.